On this theme of the many tools and approaches and how can we better understand how tools relate to each other, we are now going to hear from Jen Stamp, who will be the fourth of our Mid-Atlantic talks. Jen is an aquatic ecologist with Tetra Tech's Center for Ecological Sciences. She's worked closely with EPA ORD since 2010 on examining climate change effects on aquatic ecosystems. She works on a wide variety of projects and helped to design and develop long-term regional monitoring networks to monitor and track climate-related changes in streams, lakes, and more recently, in wetlands. Whenever you're ready, Jen.
Okay, great. Thanks, Jordan. All right, let me go ahead and pull this up. Okay, are you able to see my slide okay? Nope. Am I on mute, or are you on mute, Jordan?
Hang on, one second. Yes, we can see.
Okay, thank you. Okay, thanks everyone, and thank you, Leanne, for teeing me up. So I'm going to take what Leanne presented on and what actually Anna and Jordan presented on as well, and take it a step further, talking about all these different tools out there, and there's going to continue to be more and more tools being developed in the future. And we ended up coming up with an approach that uses a conceptual diagram to help contextualize all the different tools and at least help us in our case study figure out where each tool plugs in and how maybe it could help other people to understand where there's gaps and redundancies and areas of the bigger picture processes in a coastal wetland that need some attention. And so in terms of our approach, what we did was, as mentioned, we focused on the salt marshes for this project. And we started with the PDE watch tool as kind of the heart of our diagram. And then we brought the information from the relative wetland vulnerability framework that Anna and Jordan talked about. Plus, we also brought in other tools we were aware of, like the adaptation design tool that Leanne mentioned. And we wanted to see where all these different tools plugged in to this diagram. And the steps we followed, just in general, or just to give you the quick overview before I go into a little more detail, is one, we wanted to construct a diagram of just the watch tool alone. As Leanne mentioned, there's 6 different attributes, and then within each attribute, you can dig a little deeper and have specific metrics, or as they call them, methods that you can select. Then we dug into that case study that's been talked about a few times, as well as climate change projections specific to the Delaware Bay area. And then literature. We're certainly not the first ones to develop a conceptual diagram for salt marshes. So we made use of existing information where it was made sense to use and customized it to make sure it fit our needs. So then we went ahead with the diagram development and made sure it covered all our bases. And as mentioned, then we also brought in some tools and models and things that we were aware of that we didn't necessarily use in our own case study, but we thought might be important to demonstrate how those fit in as well. So this slide goes into a little more detail about the watch components. As Leanne mentioned, there's 6 different attributes as the model, or as the watch tool rather, currently stands. And they set this tool up so it's very flexible. And this is like if you took it off the shelf and used their Excel worksheet, you'd be able to go through these steps. But they left it open and very flexible so you could customize it or add new things in if you wanted. But we wanted the heart of our conceptual diagram to cover the attributes that they put a lot of thought into selecting. And so those include horizontal position, vertical position, biology, hydrology, soil condition, and water chemistry. And just to drill it down a little further, if you worked on their Excel workbook, which Josh might show a demo of tomorrow, you could get into like the biology tab on their worksheet, and you work through each attribute individually. And there's a number of different metrics if you use their off-the-shelf worksheet that you could pick for biology, such as above ground biomass, below ground biomass, and so on and so forth. So after we used watch to kind of form the heart of our diagram, then we brought in information from that case study that you've heard quite a bit about at this point, including this land modeling. And so for those of you who have worked with SLAM before, there's a lot of different input metrics that go into SLAM, and then the output is kind of relatively simple compared to what goes into the model, but it gives you a nice output if you're interested in projected changes in marsh acreage. And it allows you to differentiate between high and low marsh, which is also a nice feature. And so we brought in the relationships from the RWF case study and the different variables. Then we wanted to make sure we had climate components covered, even if they weren't a big focus of our initial case study. We wanted to bring in some bigger picture projections for precipitation patterns and temperature more at a global scale than a fine local scale. But we looked to the National Climate Assessment and focused on the Northeast section for that. And that's something that would be readily available for anyone who might want to try something similar, that there's some readily available information on climate projections. And then the literature, as mentioned, there's plenty of other conceptual diagrams out there for coastal wetlands. And so we looked to those and brought information from those in. In particular, there's a really good one from the Coastwide Reference Monitoring System in Louisiana that we really, really liked. So the next step was to create our conceptual diagram. And so I'll jump right to it. And I'm guessing on your end, unfortunately, going with our safe bet, we were considering doing this kind of live interactive deal, but we decided just to play it safe and go with a screenshot, knowing unfortunately you probably can't see a lot of these parts, or we'd have to zoom in for you to really get to eyeball these closely. But let me just give you the quick tour of this diagram. So the upper tiers are where you have the sources of stressors, and then the middle part is the green, for example, is the heart of the diagram, where we started with watch. So there's 4 attributes that the green part covers from watch, which include the biology, soil composition, horizontal position, and vertical position. And so then we kind of built out from there. And just to highlight some of the different color schemes you're noticing, the orange areas up on the top of the upper 2 tiers are things that are the upper level sources of stressors that are directly affected by human activities. So these are areas where if you wanted to apply management tactics, you'd actually have a shot at making some changes. And so those include things like point and non-point source pollution, boat activity, hydrologic alteration, and water quality, as well as dredging. If you look to the upper left, you'll see purple boxes. They're also scattered in different places throughout the diagram, but in the upper left is where we had the global scale climate change components, such as greenhouse gas emissions. And then you get into the global scale temperature, precipitation processes, which in turn affect different parts of the diagram. Gray boxes are factors that are not easily manipulated. Like if you wanted to go in and change the drainage contributing watershed of a site, that would be hard to do. Tidal range, fetch or wave wind exposure, those are factors that aren't the easiest things to change. Then you get into the middle section, as mentioned before, that includes some of those key watch attributes like biology, soil, and vertical and horizontal composition or position. Above that, the pink boxes are external factors that most directly affect those internal processes. So that's where you get into factors like sea level rise, storm surge, inundation depth and duration, external sediment supply. The bottom tiers are where you get into the response. And for our studies, we were focused mostly on salt marsh acreage. And within those, we looked at things like the type of marsh, was it high or low marsh, as well as the condition of the marsh. The bottom level, we didn't get into all that far, although we did touch on it. That's where you get into the ecosystem services and beneficial outputs. And so all we did, in addition to the crosswalking that Leanne talked about in her slides, was to go through, and for watch, we just highlighted, and you can see highlighted in yellow boxes, where in the diagram does watch give you coverage? And are there any gaps that we feel are important where we'd want to potentially bring in a new tool to cover? And maybe there's some areas that are redundant as well. And so then we did the same type of thing for the RWF case study. And so in this slide, it shows you the yellow boxes where all those variables plug in. And then when we looked at them together to simplify the diagram, I just excluded the parts or the boxes that we didn't cover. And it just gave me a pretty good sense of, where are the gaps, where areas that, we feel we need to add in maybe a new tool or bring some more things into the mix to give us more of a full picture for what's going on in a given ecosystem or a given area. And so we looked at, which boxes were specific to watch. Certain ones were specific or only covered by the RWF. And then there's some which are highlighted in yellow boxes that covered both. And it was obvious as we went through this that there's certain areas we could do more. So for example, let's say you run the watch tool, or you run a site through the watch tool and you realize there's a particular problem, but you don't know what's causing that problem yet. So then you'd get into the stressor identification process. And once you figure out what the issues are, what the sources of the stresses are, then you'd get into management tactics to address those issues. And so that would be where you could have a potential plugin with the adaptation design tool. Once you get to a point where you're picking your management tactics, ideally you want to take those extra steps in the adaptation design tool to make sure those are climate smart practices and you're doing as good a job as you can to address resiliency. And there are some good EPA resources as well, or at least the EPA EnviroFacts website has a lot of geospatial data on things like point and non-point source pollution, where you could go and grab information to populate that part of your diagram. Another area that we could do more on is the last level of the diagram with the ecosystem services and beneficial outputs. And so we want to give a shout out to the work that Ann Kuhn and a number of collaborators are doing on the coastal resiliency decision support system tool, or DSS tool. And so they're working on tools that help people with flood attenuation in particular, and other services related to mitigating or reducing potential costs and impacts from storm surge and sea level rise and all the other factors we've been talking about this morning. But there's work going on with that, with Anne and those collaborators. It's going to be a web-based tool. It's in progress right now. And so they'll embed it in a story map and make it as user-friendly as possible. And so we have her contact information here in case you'd like to find out more information. And right now that work's focused on the Chesapeake Bay, but I imagine they'll be expanding it or looking to expand it beyond just that region in the future. And I did want to mention too that they're going to add a component to it that addresses carbon sequestration and blue carbon. So I guess to summarize things, we'd love to get your feedback on whether you think this type of approach for trying to work through or navigate all the different tools out there and options is helpful, or to us, it helped us contextualize things and make some decisions. Did we feel we were adequately covering the parts of this diagram or larger ecosystem that we felt need to be covered for our purposes? Certainly there's plenty to do if you think this idea has potential to improve it. Like if I went to the next slide, just to give you a few thoughts on what we've been thinking about, like I'd love to make this diagram interactive. So like maybe you think, for example, nutrients is an issue at your site. So you'd ideally be able to go in, click on nutrients, and it would take you a step further and talk about the mechanisms via which nutrients could negatively affect your site. And then it could take you or allow you to click even further if you suspect nutrients are a problem and want to start monitoring for them. It could give you a protocol document so you could get more information on what it would take to start monitoring for nutrients. And then you could also have a link to management tactics that people have been employing to deal with nutrient issues, and ideally, if available, information on success rates, how well they've been working. So anyway, we thought the idea has some potential, or it just helped us get our heads around how to navigate all the different tools out there, and we'd love to get your feedback. So that's all I have. Thank you.
Thank you. Thank you so much, Jen. I must say I'm wowed by that conceptual diagram. And I want to thank you and Leanne for those fascinating presentations. Jordan, did you want to say something before we launch into the Q&A?
Nope, go ahead. We're good.
Okay. Great. So again, please we're using the chat for the Q&A. And if you have a question for a specific presenter, please put Q and then their name next to it. If you have a comment or feedback, use a C next to it. And it sounds like Jen and Leanne would be very interested in any feedback on their conceptual diagram. But of course, we're ready for questions. So Joan, do we have any questions that came up during the presentations?
Yes, Joe, while we're waiting for additional questions, I'll just review some comments or questions that came up. So one was from Anne, who in the context of discussing assessment tools, had asked about using the USGS UVVR, which was the unvegetated vegetated ratio for salt marshes, and she provided a link to that. And then further on, there was a question as to where someone could find various tools, the Watch or the RWVF, and directions for new users. And Jordan pointed out that we will provide links to those resources on the workshop website, along with the presentations after the workshop. So if anyone has any questions, they should refer to the website. Taryn asked how often did insufficient data or monitoring prevent the effectiveness of various tools or data surrogates when necessary, good, and available. Leanne addressed that question. Leanne, I don't know if you want to just jump in and respond to that again, or I can read what you responded in the chat.
Oh, just what I have in the chats.
Okay. So Leanne said she thought that they were lucky to have a lot of data at their disposal to look at the things, especially on the ground data. And they hope to continue working on ways to overcome data paucity issues, including analyzing existing data to see where surrogates could work, and maybe even future field-based workshops for Watch.
Great. Well, thank you, Joan.
Sure.
Not seeing any other final call for questions. Jen, did you want to make a comment? You're on.
Okay, it helps if I take myself off mute. Yeah, I just wanted to say something to help tee up the afternoon session too. Like in regard to the conceptual diagram, one piece that's missing that's really important is stakeholder engagement, and ideally that's happening as you go through the process we've talked about this morning. Our processes were data driven, like you'd go through maybe and do your vulnerability assessment and come up with a list of candidate sites based on the data we were looking at. But if you don't have the stakeholders to go along with it and champion your cause, then that certainly decreases the chances of you actually being able to implement a project. So I just want to say I'm looking forward to the afternoon sessions and talks so that we can hear more about that side of things.
Thank you, Jen. That does tee us up well for this afternoon. And
Okay.
is there?
Joe, there's one more comment that just came in from Marilyn. Said it is great that the group had large amount of on the ground data with regard to initiating new project. How can your work be used to indicate which variables are most critical to measure?
Who wants to take that one? Jen, Leanne?
Yeah, I can hop in, and if somebody else wants to jump in after me. I think a lot of when we work through this, depending on what type of data we have, I think the key the key thing that I always come back to is what's the goal? So I think what data and what variables and what metrics are most important are going to be highly dependent on what questions you're actually answering and what you're trying to achieve.
Yeah, and I think this is Jen with Leanne. As you guys get more experience using the watch tool, that might help you guys figure out too, like what I know when you're comparing data from a given site to reference site, or you're trying to set a bar for a given site, sometimes we know we're lacking in what the reference condition looks like. So I guess, yeah, the more you guys use the tool and have other people using it, maybe that helps us figure out what we really need to bolster our knowledge on. But yeah, it's a good question. And like she said, I guess it's this unsatisfying answer too of it depends.
But thanks for bringing that up too, Jen, that, you know, eventually as we build out the watch tool and other things like that, we do hope to make a lot of the examples that come from it public so that folks can see, oh, like maybe, you know, this question is similar to mine, so I can just use the same variables.
Great. Well, thank you, both of you, for those responses. And don't see any other questions, Joan, in the
No, I
chat.
don't.
So
Yeah.